Good morning. Today we have to discuss second order ordinary differential equation with constant coefficient. Already we have solved for first order differential equation and finding integrating factors. Then today we have to discuss the second order problem. So linear differential equation with constant coefficients. The general form of the equation is d power n into y divided by dx power n plus a1 into d power n minus 1 into y divided by dx power n minus 1 and so on, plus an into y equal to capital X, and capital X is a function of x and a1, a2, etc. an are real constants. In equation 1 we have to convert into d power n divided by dx power n is equal to capital D power n. Then the equation becomes d power n plus a1 into d power n minus 1 plus etc. an into y equal to capital X. The equation contains n roots, then the roots are distinct or the roots are equal and distinct, the roots are complex and so on. The equation is n roots, then the equation is homogeneous and non-homogeneous. Here capital X equal to 0, then the equation is homogeneous. The homogeneous solution contains only for complementary function, but non-homogeneous solution contains particular integral. The particular integral, we have to find the complementary function and also particular integral. The general solution of the second order differential equation is y of x equal to complementary function plus particular integral is the general solution of the given second order ordinary differential equation. But complementary function contains arbitrary constants because the given equation is nth order. So n arbitrary constants are complementary function contains n arbitrary constants, but particular integral does not contains any arbitrary constants because the particular integral contains only for functions of x only. Then to find the complementary function of the given differential equation. So we have to taking equation number 1, the convert into d power n divided by dx power n equal to d power n. The equation 1 becomes d power n plus a1 into d power n minus 1 plus a2 into d power n minus 2 plus and so on, plus an into y equal to capital X or f of d into y equal to capital X. So consider as equation number 2. Then we have to take the homogeneous solution. The homogeneous is nothing but capital X equal to 0. So d power n plus a1 into d power n minus 1 plus a2 into d power n minus 2 plus an into y equal to 0 or f of d into y equal to 0. We have to consider the auxiliary equation. The auxiliary equation is y equal to e power mx is the solution of the given differential equation because the first order equation is of the form the solution contains exponential or power series, all the solutions based on the power series. Then equation 3 is equivalent to, that is nothing but factorize the equation number 3, then d minus m1 into d minus m2 etc. d minus m1 into y equal to 0. We will take the second order ODE, d minus m1 into d minus m2 into y equal to 0. Consider as equation number 4. We now proceed to find the general solution of equation 4. Let d minus m1 into y equal to u. Then equation 4 reduced to d minus m1 into u equal to 0. So that is nothing but du by dx minus m2 into u equal to 0. We have to using the variable separable Then du by u equal to minus m2 into dx equal to 0. Integrating on both sides, we get du by u is nothing but log u minus m2 x equal to c. Then minus m2 x take into right side, so log u equal to c plus m2 into x. Cancel logarithmic, so u equal to c e power m2 x. Then we have to consider the solution. Substitute this value in d minus m1 into y equal to u. We can assume that a solution of the equation 3 is of the form y equal to e power mx. Then since dy is nothing but differentiating y with respect to x, then dy equal to m into e power mx and d squared y equal to m squared into e power mx and so on. So d power n into y equal to m power n into e power mx. So substitute these values in equation 3, becomes m power n plus a1 into m power n minus 1 plus a2 into m power n minus 2 plus and so on plus an into e power mx equal to 0. Here a dot b equal to 0, either a equal to 0 or b equal to 0. But we have to taking y equal to e power mx be the solution of the equation. So here e power mx is not equal to 0. So m power n plus a1 into m power n minus 1 plus a2 into m power n minus 2 plus and so on plus an equal to 0. The equation is called the auxiliary equation because we have to access the solution for y equal to e power mx. Then the equation is called the auxiliary equation. The auxiliary equation is the nth order equation. So the equation contains n roots. So the nth order equation contains n roots. Say we have to consider the roots for m1, m2 and so on to mn. Case 1, when all the roots of the auxiliary equation are real and distinct or different. So let m1, m2 etc. mn, then the solution is y of x equal to c1 into e power mn x, c plus c2 into e power m2 x plus etc. cn into e power mn x. Because the solutions are linearly independent, so we have to consider the linear combination of the solutions. So we get y of x equal to c1 into e power m1 x plus c2 into e power m2 x plus and so on plus cn into e power mn x. Then second case, when auxiliary equation has an equal root, so we have to consider the equation number 3. So d minus m1 into d minus m1 y equal to 0. Let d minus m1 into y equal to v. Then d minus m1 into v equal to 0. That is nothing but dv by dx minus m1 into v equal to 0. You have to using the variable separable dv by v minus m1 into dx equal to 0 and integrating on both sides, then log v minus m1 into x equal to c1, then log v equal to c1 plus m1 into x, then cancel the logarithmic, then v equal to c1 into e power m1 x. So you have to use the value for v equal to c1 into e power m1 x in the particular equation d minus m1 into v y equal to v. Then the equation becomes d minus m1 into y equal to c1 into e power m1 x and dy by dx, that is change dy by dx minus m1 into y equal to c1 into e power m1 x, which is the linear equation of first order. Then the integrating factor is e power integral p dx. Here p is the m1 into x. So that is the e power minus m1 x is the integrating factor of the particular equation. Then find the general solution. So general solution is nothing but y into integrating factor equal to integral q into integrating factor into dx plus c2. Then c1 into e power m1 x into c power into e power m1 x. So, e power 0, then c1 into e power 0 is e power 0 is nothing but 1, then c1 into dx plus c2, then divide e power minus m1 x. So, y of x equal to c1 x plus c2 into e power m1 x. Then case example, solve d power 4 minus 5 d squared plus 4 into y equal to 0. So, the given differential equation is fourth order homogeneous ordinary differential equation. The homogeneous equation contains only the complementary function is the general solution of the given differential equation. So, we have to factorize the particular equation. The particular equation is factorized into d squared minus 4 into d squared minus 1. The ordinary differential equation order is fourth order. So, fourth order equation contains 4 roots. The roots are d squared minus 4 equal to 0 and d squared minus 1 equal to 0. The auxiliary equation becomes m squared minus 4 into m squared minus 1 equal to 0. So, m equal to plus or minus 2 and m equal to plus or minus 1. The roots are all distinct and real. So, the complementary function is the general solution. So, y of x equal to c1 into e power 2x plus c2 into e power minus 2x plus c3 into e power x plus c4 into e power minus x. So, this is the general solution of the particular equation. Then we have to find the shortcut method for the particular integral. There are 4 forms here, the capital X equal to e power ax and capital X equal to sin ax or cos ax, and capital X equal to polynomial a0 plus a1x plus a2 etc. plus an into x power n, and capital X into v. The v is nothing but the combination of e power ax, sin ax or cos ax and the polynomial. First, we have to find the particular integral in the form of capital X equal to e power ax. Then formula 1a, we have to find the particular integral equal to, suppose f of d is a polynomial, 1 divided by f of d equal to f of d into e power x, replace d by a, that is nothing but 1 divided by f of a into e power ax. When f of a not equal to 0, we have to replace d by a. Suppose f of a equal to 0, then the particular integral is, we have to x power n divided by n factorial into e power ax. So, that is nothing but, so d minus a into e power ax, put replace d by a, then the value is 0. So, 1 by 0 is nothing but infinity. So, here particular integral is does not defined. So, we have to differentiating, put x in numerator and denominator we have to differentiating with respect to d, then x divided by 1. So, 1 divided by d minus a into e power ax is nothing but x into e power ax. Then working rule for finding the particular integral of f of d into y equal to capital X when capital X equal to e power ax. Step 1, if f of a not equal to 0, then we have to replace d by a. Suppose f of a equal to 0, then the differential equation order, so suppose the order is 1, numerator put x, then differentiating denominator, we have to get the particular integral. So, this is the general form for nth order. So, that is nothing but particular integral equal to x power n divided by n factorial into e power ax. Then another example, solve d square minus 3d plus 2 into y equal to e power 5x. The given equation is second order a linear non-homogeneous equation with constant coefficients. So given equation is second order equation. So second order equation contains two roots. So we have to find the auxiliary equation. So take y equal to e power mx be the solution of the given differential equation. We have to find the dy and d squared y. So substitute these values in given equation. The equation becomes m squared into e power mx minus 3m into e power mx plus 2 e power mx equal to 0. Then we have to take e power mx outside, then the equation reduced to m square minus 3m plus 2 equal to 0. Here e power mx is not equal to 0 and m square minus 3m plus 2 equal to 0. This is called the auxiliary equation. Then factorize the auxiliary equation. So m minus 1 into m minus 2 equal to 0. Then m equal to 1 comma 2 are the roots. The roots are real and distinct. Then the solution is y of the complementary function is c1 into e power x plus c2 into e power 2x. Then we have to find the particular integral. Then particular integral equal to 1 divided by d square minus 3d plus 2 into e power 5x. So replace d by 5, then that is nothing but the value of a is 5 here. The value of a is 5. Then replace d by a. So that is nothing but replace d by 5. Then 5 square minus 3 into 5 plus 2. So 5 squared is nothing but 25. 25 minus 15 plus 2. So 25 plus 2 is 27 minus 15 is nothing but 12. So the particular integral is 1 by 12 into e power 5x. The given differential equation is non-homogeneous. The general solution contains y equal to complementary function plus particular integral. So therefore the general solution is the complementary function is nothing but c1 e power x plus c2 into e power 2x plus particular integral is 1 by 12 into e power 5x. Therefore the general solution is c1 e power x plus c2 into e power 2x plus 1 by 12 into e power 5x. So the second order non-homogeneous linear ordinary differential equation given, the general solution is y equal to c1 e power x plus c2 into e power 2x plus 1 by 12 into e power 5x. Then example 3, solve d squared minus 3d plus 2 into y equal to e power x. Then we have to find the same way, we have to get the auxiliary equation and the roots. Here the roots are distinct and complementary function is c1 into e power x plus c2 into e power 2x. What is the difference between previous problem and this problem? The particular integral contains, so substitute d by the here a value is 1, then replace d by a, then d by 1. So replace d by 1, 1 minus 3 plus 2, we have to add 1 divided by 0. So we have to use the formula 2a. So that is nothing but x power n divided by n factorial into e power ax. So here we have to put x in numerator, then differentiating denominator, that is nothing but 2d minus 3d. So we have to put d by 1, that is nothing but 2 minus 3 here minus sign here. That is nothing but x divided by 1 factorial into e power x. So there is a difference between the problem is the numerator, the denominator contains 0. The previous problem is decimate problem. So the previous problem depends on formula 1a and example 3 depends on formula 2a. Then shortcut method of finding particular integral when capital X equal to sin ax or cos ax, where a is a constant. Then case 1, when f of d can be expressed as pi of d squared and pi of minus a squared not equal to 0, we shall using the formulas 1 divided by pi of d squared into sin ax equal to 1 divided by pi of minus a squared into sin ax. That is nothing but we have to replace the values for only we have to replace d squared by the coefficient of sin ax, that is nothing but a we have to square and put negative sign we have to replace only for the part of d squared only, not in d. Suppose we have to put the value d squared by minus a squared, the denominator gets 0, the case 2 will be formed, otherwise the case 1 will be followed. Then case 2, when f of d can be expressed as pi of d squared and pi of minus a squared equal to 0, shall following formula we have to use, that is nothing but 1 divided by f of t into e power ax into v. So this form is I have told already, that is a fourth one. So we have to e power ax into v. So we have to replace e power plus ax, that is nothing but replace f of d by d plus a. Then another example for this type. Then solve d squared plus 1 into cos 2x. The given differential equation is second order and non-homogeneous. Here capital X is nothing but cos 2x. Then we have to find the previous auxiliary equation for previous problem. Then that is nothing but the auxiliary equation is m squared plus 1 equal to 0, m equal to plus or minus I. Here the roots are complex roots. So the roots will be complex. The complementary function is of the form e power alpha x into a cos beta x plus b sin beta x. Here alpha equal to 0, only beta equal to 1. Then the complementary function becomes c1 into cos x plus c2 into sin x. Then we have to find the particular integral. So particular integral is 1 divided by d squared plus 1 into cos 2x. So replace d squared by minus 4. Then here we have to replace d squared by minus 4. So 1 divided by minus 4 plus 1 into cos x. So that is nothing but minus 1 by 3 into cos 2x. The general solution is y of x equal to complementary function plus particular integral. So complementary function is c1 cos x plus c2 sin x. Then particular integral is minus 1 by 3 into cos 2x. Then another example. So solve d squared minus 3d plus 2 into y equal to sin 3x. Then the auxiliary equation is m squared minus 3m plus 2 into y equal to 0. So m minus 1 into factorize into m minus 1 into m minus 2 equal to 0. So m equal to 1 comma 2, the roots are real and distinct. The complementary function is c1 into e power x plus c2 into e power 2x. Then find the particular integral. So 1 divided by d squared minus 3d plus 2 into sin 3x. We have to replace only for d squared. So that is nothing but replace d squared by the coefficient of x, that is nothing but 3. Then square and put negative sign. So replace d squared by minus 9. So 1 divided by minus 9 minus 3d plus 2. Then add, we have to take negative sign outside. So 1 divided by 3d plus 7 into sin 3x. So we have to find the, what is mean by, we have to find the conjugate. So that is nothing but 3d minus 7. So 3d, we have to find the conjugate, then multiply and divide. Then minus of 3d minus 7, 1 divided by 3d plus 7 into 3d minus 7, that is nothing but a plus b into a minus b into sin 3x. Then a plus b into a minus b is nothing but a squared minus b squared. So 9d squared minus 7 squared into sin 3x. then 3d minus 7 into, so we have to replace d squared by minus 9 again, so 9 into minus 9 minus 49 into sin 3x. Then we have to add 1 divided by 30 into sin x, so that is nothing but we have to cancel the negative sign. Then we have to multiply for sin 3x inside. D is nothing but differentiating the capital X. The capital X is here sin 3x, differentiating with respect to x. So that is nothing but 3 into 3 cos 3x. So 3 into 3 is 9 cos 3x minus 7 into sin 3x. So this is the particular integral of the form. Here we have to put the value for 3 and square, put negative sign here. So this is the another form. So we have to find the value for the particular integral for the this type. Then the general solution is y of x equal to c1 into e power x plus c2 into e power 2x plus 9 cos 3x minus 7 sin 3x divided by 130. Then short method of finding the particular integral in the another form. Then third one, when capital X equal to x power m, m being an positive integer. Here we have to using the formula for 1 plus x whole power minus 1 and 1 minus x whole power minus 1 and 1 plus x whole power minus 2 and 1 plus x 1 minus x whole power minus 2. 1 plus x whole power minus 1 is nothing but 1 minus x plus x squared plus etc. 1 minus x whole power minus 1 is nothing but 1 plus x squared plus and so on. And 1 plus x whole power minus 2 is nothing but 1 minus 2x plus 3x squared and so on. And 1 minus x whole power minus 2 is nothing but 1 plus 2x plus 3x squared plus and so on. Then how to find the particular integral for the particular type? So bring out the lowest degree term of f of d, so that the remaining factor of the denominator is of the form I have already told. This is the form 1 plus pi of d whole power n or 1 minus pi of d whole power n, n being an positive integer. Then step 2, so we take 1 plus pi of d whole power n or 1 minus f d pi of 1, its numerator becomes 1 plus pi of d whole power minus 1 or 1 minus pi of d whole power minus n, that is nothing but 1 divided by 1 plus pi of d the whole power n. So 1 divided by 1 plus pi of d whole power n is nothing but 1 plus pi of d whole power minus n. Then example 6, solve d squared minus 4d plus 4 into y equal to x squared. So we have to find the auxiliary equation. The auxiliary equation becomes m squared minus 4m plus 4 equal to 0. We have to factorize m using the formula for a minus b the whole square, that is nothing but m minus 2 the whole square. So here m equal to 2 comma 2, the roots are real and equal roots. So the complementary function becomes c1x plus c2 into e power 2x. Then find the particular integral. So 1 divided by d square minus 4d into plus 4. So we have to convert into 1 plus pi of d form. So we have to take 4 outside. So that is nothing but 1 by 4 into 1 plus, that is nothing but this mistake, 1 plus d square minus 4d whole divided by 4. The particular part becomes 1 by 4 into 1 plus d square minus 4d by 4 into whole inverse into x squared. We have to use the formula for 1 plus xc whole power minus 1. So 1 plus xc whole power minus 1 is nothing but 1 minus x plus x square plus and so on. Here the value of x squared only, then we have to take only two terms. So that is nothing but 1 by 4 into 1 minus x plus x square terms contains only for the particular value of 4d by 4. The remaining terms will be neglected. So we have to multiply x squared inside. So that is nothing but 1 by 4 into x squared minus, so d squared is nothing but differentiating x with respect to 2 times. So that is nothing but x squared we have to differentiate, then we get only 2. Then 4 into d is nothing but differentiating x squared one time. So that is nothing but 2 into minus 8x whole divided by 4 plus 2. Then 1 by 8 into 2x squared plus 4x plus 3. So that is nothing but we have to cancel the particular term x squared minus 1 by 2 plus 2x. Then we have to x squared minus 2x plus 2 minus 1 by 2 is nothing but 3 by 2. Then take 2 outside, then 1 by 8 into 2x squared plus 4x plus 3. So therefore the general solution is y equal to c1x plus c2 into e power 2x plus 1 by 8 into 2x squared plus 4x plus 3 is the general solution of the particular equation. Thank you.